Today we're going to be doing a introduction and understanding on the mean value theorem. So the mean value theorem states that if f of x, a function, is differentiable and continuous on the interval which is open, a, b, then there exists such a x is equal to c that f prime of c is equal to fb minus fa over b minus a, or in other words, the slope of the secant line that passes through the open interval of a and b. So we are going to be proving this theorem in future videos, but for now you just have to get an understanding for what it is. And you see here that within this function right here, let us suppose that this here is a comma f of a, and let's suppose that this point right here is called b comma f of b. And if we draw it down according to the x coordinate, this will be a, and this will be b. So this region will be bounded between A and B. So what it means is that there exists such a point on this line, which I'm going to do in red. There exists such a point right here, for example, such that the secant line that passes through A comma f of A and B comma f of B will have the same slope as the tangent line of that point. So if I draw ourselves a rough line right there, then there exists such another point within this interval that the tangent slope to that point will be the same as the secant slope between the interval. And that is all the mean value theorem states. And this will come useful in real life engineering and sciences. So this is an important theorem to learn and understand in calculus. So when we are dealing with mean value theorem, it is often good to visualize and do an example of what it really is talking about. So let's say we have a function to be equal to x to the third power plus 3x squared plus 5x plus 7. And I want to find the mean value theorem, applying it between the interval of 1 comma 7. Okay, actually let's do 1 comma 2 for simplicity. So 1 comma 2. That is our bounded range on f of x. And what we're going to do is that we are going to first find the secant slope that goes through these points in order to apply the mean value theorem and find out the point which has the tangent slope equal to the secant slope that passes through 1, 2. So f of 1 is the same thing as 1 plus 3 plus 5 plus 7, which is the same thing as 4 plus 12, which is the same thing as 16. F of 2 will be 2 to the third power, which is 8, plus 3 times 4, plus 10 plus 7, which is the same thing as 8 plus 12 plus 17, which is the same thing as 29 plus 8, which is the same thing as 37. So our first point is 1 comma 16. Our second point is 2 comma 37. And what is the secant slope that passes through these 2 points? Well, the secant slope will be the y coordinates f of b minus f of a. So I'm going to let f of b be equal to 37, f of a be equal to 16. 37 minus 16 over 2 minus 1. This is just what a slope definition is. Rise over run. This is then equal to 21. 21 over 1 is the same thing as 21. Hence, the secant slope that passes through 1 comma 16 and 2 comma 37 will be 21. So there must be a point between this interval such that the x value will have the derivative be equal to 21. And to find that, we are going to do it right now. First, we find the derivative of f of x, and we can do so by applying the power rule. And remember, this is differentiating in terms in respect to x. So this is equal to 3x squared plus 6x plus 5. And since we have to have a derivative, which the derivative is the same thing as the slope, the instantaneous slope, be equal to the secant slope of 21, we must set the derivative of 3x squared plus 6x plus 5 to be equal to 21. Subtract 21 on both sides, we get 3x squared plus 6x minus 16 is equal to 0, and we solve for x. Hence, we can use the quadratic formula to do so. X is equal to negative b, which is negative 6, plus minus the square root of b squared 36 minus 4 times 3 times 16. And since 16 is negative, this becomes a plus sign. So 3 times 16 is 4 times 48, which is the same thing as 192. So 36 plus 192 square rooted divided by 2a, which is 6, which is equal to negative 6 plus minus the square root of 228 over 6. And 228 is divisible by 4, so 228 is the same thing as 4 times 57. 57 is divisible by 3, which is the same thing as 4 times 3 times 19. And 4 can be square rooted to be 2, so this becomes negative 6 plus minus the square root of 19 times 3, which is 57, times 2 over 6. And we can divide 2 on both sides to get negative 3 plus minus the square root of 57 over 3. So these are what the x value might be, which has the same tangent slope as 21. But we must see here, is there going to be an extraneous solution? Because it has to be bounded between the interval of 1 and 2. If it's not between 1 and 2, then that will be an extraneous solution. So the square root of 57, well, we can prime factorize. 57 is equal to 3 times 19. The square root of 3 is about 1.7, and the square root of 19 will be about 4 point something. So multiply together, we will get a rough estimate of about 5.8. That's just a very rough estimate. So negative 3 plus 5.8 divided by 3 will definitely be between 1 and 2, meaning that x is equal to negative 3 plus the square root of 57 divided by 2, or divided by 3, will be a solution to this question. And what about minus? Well, if negative 3 is subtracting this, then it will be in the negative range, and that is not between 1 and 2. Hence, that would be an extraneous solution, and we only take the plus symbol. So the solution to this question will be x is equal to negative 3 plus the square root of 57 over 3, meaning that the derivative, when x is equal to this quantity, will have the derivative slope, or have the derivative be equal to 21, which is the secant slope that goes through the restriction, the interval of 1, 2. So I hope that gives you an insight to what the mean value theorem is, and we'll be diving into more complex examples in later videos.